inclined plane. Alright, let's consider a mass m resting on a plane surface. Its weight mg acts vertically down. There you are. Now this is the force pressing the object to the surface as I just showed it to you. Now what happens if the plane is now tilted to form an inclined plane of inclination theta like this? Well, the weight mg is still acting vertically down. You see, no matter how you place an object, its weight will be always vertically down. So what is the direction in which I can draw the weight vector? Look at this. The weight is acting vertically down. Only part of this weight is now pressing the two surfaces together. The other part is pulling it down the plane. Now, a line drawn at right angles to the plane, look at this. A line drawn at right angles to the plane makes an angle with the direction of the weight. Can you tell me what is this angle equal to? That is the angle between the vertical, that is the direction of the weight, and a line drawn at right angles to this plane. That angle will be the same as this angle. Now, how do you know? It's a simple geometry. Let me explain that to you. There is a result in geometry that says if you have two lines that make an angle theta. Now draw a line perpendicular to the first line. There you are. And draw another line perpendicular to the second line. There you are. So you notice that these are the two initial lines making an angle theta. I drew a third line perpendicular to the first line, then a fourth line perpendicular to the second line. Now the result says the angle between the first two lines will be the same as the angle between the lines 3 and 4. In other words, lines 1 and 3 are perpendicular, lines 2 and 4 are perpendicular. Therefore, angle between lines 1 and 2 equal to the angle between lines 3 and 4. Now the same here. If this is one line and this is the second line, let me draw that for you here. Now this is the line 1. I'm going to call it line 1. And this is line 2. Now, line 3 is at right angles to line 2, and line 4 is at right angles to line 1. Therefore, the angle between lines 1 and 2 equal to angles between lines 2 and 4. This angle. Well, okay, so that means this angle is the same as theta. Okay, in that case you tell me, you know how to find the components of a vector. Here we have a vector that makes an angle theta with this line. Now this vector has a component along that line and a component along the plane. Can you tell me what those components are? What is the component of this weight mg at right angles to the plane along this line? Since this angle is theta, that component will be mg cos theta. The vector component of mg at right angles to the plane is mg cos theta, and the vector component of mg down the plane is mg sine theta. Very, very important results. You cannot ignore it. Alright? Let me bring back my inclined plane and let's have a look at it. Well, now here is the inclined plane. What is the direction of the weight? The weight will be acting vertically down. The component of the weight acting down the plane will be mg sine theta, and the component of the weight that is pressing the two surfaces together at right angles will be mg cos theta. And you know, as theta increases, cos theta decreases and sine theta increases. You can see mg sine theta increases and mg cos theta decreases. You understand that? So this phenomenon is very important. The weight of the block will be acting vertically down. Its component mg sine theta acts down the plane, and the component mg cos theta is pressing the two surfaces together. Okay, so the component mg cos theta presses the object onto the surface. The surface in turn applies the force of reaction. You see, this mg cos theta is pressing this surface at right angles, and the surface in turn applies the force of reaction, which is equal but opposite to mg cos theta. There you have the force of reaction, which we are going to represent as F sub n, the normal force. So this is the normal force, which is the same as mg cos theta but directed in the opposite direction. There is no net force at right angles. You see, there is no net force in this direction. Therefore, we can say the normal force F sub n equal to mg cos theta. And what does mg sine theta do? Mg sine theta pulls the object down the plane. Now this is the net force on the object. Here we assume that there is no frictional force between the block and the plane. In the next lesson we are going to look at friction. So then we will change our story. But today there is no friction between the block and the plane. Therefore, mg sine theta is the net force pulling the objects down the plane, and it produces an acceleration a on the object down the plane. So we know that the net force equal to ma, F net equal to ma, and that means the net force is mg sine theta, and that mg sine theta equal to ma, and therefore a equal to g sine theta. When you keep an object on an inclined plane, it will accelerate down the plane, and what will be its acceleration? Will be equal to g sine theta. So there is a difference between a freely falling object. A freely falling object has an acceleration g, whereas if the object is moving down the plane, its acceleration will be g sine theta, where theta is the angle of inclination. And when the angle theta increases, the force pressing the object to the surface will decrease, and the force pulling it down will increase, as I just showed it to you. Is that right? Okay. I'm going to stop with this part of the lesson here. I will record a second part where we will use these concepts to solve problems. That's what we normally do. We will be using the concepts we developed in the theory part to solve problems. Alright, I will see you for that part a little while later.